Okay, so optimization problems, we're applying max and min. That's what we're doing. We know how to find them already. We're going to apply it, so it's going to be more involved. Okay, the first thing is a manufacturer wants to design an open box having a square base and a surface area of 108 inches. What is the dimensions? What dimensions will produce a box with the maximum volume? So some things I need to pay attention is I'm looking for the maximum what? Volume. Okay, so volume is the function I'm going to be, if I'm max and min, I'm thinking first derivative critical number, yes? That's what should I be. But the function I need to worry about is the volume one, yes? But they also gave me what? Surface area. So we're going to have two equations, aren't we? Okay, so first of all, we probably should draw ourselves a picture. Something rough that I can work with. An open box that has a square base, right? So what does it mean to have a square base?
The bottom is shaped like a square.
Okay, so this, if this is x, so would this be yes?
Yes.
Okay, and how do I find height? How do I find volume?
Side times side times side.
Well, I never said the height. I just said the bottom was square. Yes?
Yes.
Now, it could be a cube. We don't know that. So we know the bottom is square. So we need a height. So can we just label it h? Yes? Now, be leery of putting x, x, and x because it said nothing about being a cube. Does everyone understand what I'm saying?
Yes.
Okay, if it said it wanted a cube box, then it would be x, x, and x, right? Okay, so how do I find surface area? What is surface area? Just in general, what is it?
It's how much area the surface.
On the surface, yes?
Mm-hmm.
Okay, so this is a box that has how many sides?
1, 2, 4.
4 sides and a bottom, yes? Okay, so are all the sides the same?
Yes.
Yes. So what is the area of one side? What's the area here?
X squared. No.
No.
No, 108.
No. What is the area of this side of the box? How do I find area?
Length times width.
Length times width. What's the length?
XH.
It's XH is that area. Yes?
Yes.
Okay. I filled it in too much. It was bugging me. Okay, so that area is XH. How many of those do I have?
4.
I have 4. I have 4 sides, yes?
Yes.
Okay. And then I have to add the bottom. What's the bottom?
X squared.
X squared. So I have 108 equals 4xh plus x squared, yes?
Mm-hmm.
Okay. And we know we're going to be working with what? Volume. So I'm going to move that over here. So the volume of this box would be what? What would that equation be with that box? Specifically that box.
X squared H.
X squared h.
Yes.
Because it'd be the area of the base times the height. Yes?
Well, what happened to the 4?
Well, no, this is volume.
Yeah.
The volume of this box would be x times h.
Oh.
Yes? Base times width times height. Okay, so I have 2 equations, and I want to work with the volume one. So what I need to do with this, the surface area, is to get it into one variable. And our brain likes to work with h's better than, with x's better than h's, doesn't it?
Yeah.
Yeah? So we probably should solve this for h, and then substitute it into my volume. That'd be easy to do, right? Okay, well, I'm solving this for h. So I guess I would subtract over the x squared, wouldn't I?
Divide?
No, it's plus. Wouldn't I add it or subtract it over?
Yeah. Oh.
Okay, so I'd have 108 minus x squared equals 4xh. Then what? I'm solving for h. I want h equals when I'm done. Divide by 4x?
Yes.
So h equals 108. Actually, I'm going to write it a little bit differently because I don't want to look at it like that. I'm going to put 1/4 1 over 4x times 108 minus x squared. Probably still want that into one thing, don't you? Do you want a multiplication or you want to distribute it and get what we get?
Distribute.
Distribute it? Okay. So, let's see. Maybe not. Well, we got to plug it in here, don't we? So we're plugging it in for this h, aren't we?
Yeah.
Yeah. So maybe if we do plug it in like this, it'd be easier than like this. Because then you'd have, or either one. Which one do you want to do? The top one or the bottom one?
I did the top. Okay.
Which one? Top or bottom? Bottom? Okay. So we're plugging that in for h. So we have v equals x squared times 1 over 4x times 108 minus x squared. And we know we have to take the derivative of this, so you should definitely not want to stop here with our simplification, should we?
No.
No. So we need to do some work with this. Let's see. So if I have x squared times 1 over 4x, what can I do with that?
Take out an x.
Take a factor out an x. So I have that. So what I have is 1/4 x times 108 minus x squared. Now, I could do the product property for derivative, right? Because we know we have to take the derivative of this. We already know that, right, from the beginning. But do you guys want to distribute, or do you, and then we could just do derivative simply, or do you want to do the product property? What do you guys want to do?
Distribute it.
Distribute it?
Yeah.
Okay, so I need 1/4 of 108. What's that? 4 goes into 10. How many times? 2. With 2 left over?
It'll be 27.
So 27x
Yep.
minus, ooh, wouldn't that be 1/4 x cubed?
Yep.
Okay. So now I need to take the what?
Derivative.
Derivative. So take the derivative of that.
27.
So dv dx. Because we're taking the derivative of v with respect to what? X. Hopefully you have 27 minus 3/4 x squared.
Yep.
Okay. So that is my derivative right here. But we learned in this chapter we need to find the critical numbers of the first derivative to find the max or min, correct? And that's another reason why we did this all in x, because x is the x-axis, right? Okay, so personally, I'm going to add over 3/4 x squared. How about you guys? Yes? So I get 27 equals 3/4 x squared. I'm solving for x. Now what do I do?
Divide. No.
By?
3/4.
Okay, or multiply by
3/4. No, 4/3.
4/3. Multiply by the reciprocal, right?
Yep.
Okay, so I have, why does it do that? Okay, so I have 4/3 times 27 equals x squared, right?
Yeah.
So 3 goes into 27. How many times?
9.
9. 9 times 4 is?
36.
So I have 36 equals x squared.
And that's going to equal 6.
Mm-mm.
No, never mind.
You're close. What's the square root of 36, guys? There's 2 answers.
Plus or minus.
Plus or minus 6. Okay. But, let's go back.
6, but it's also negative 6.
Right. But now, guys, we have plus or minus 6. Can the dimensions of a box be negative 6?
No.
No. Okay. Now, if these were an equation, like if it was 10 minus 6, could we use minus 6? Like if it was 10 minus x, could we use the negative 6?
Yeah.
Again. So you have to look back at your original. A lot of things, we don't have limitations on domains, do we? But once we put them into an application, are we going to have limitations on domains?
Yes.
Yes. Okay, so now we know it's only x equals what?
6.
6. So x is 6, but it asks me for the dimensions, yes? So I have to plug this back in. Where do you want to plug it back in?
Let's plug it back in.
What about like right here?
Where? I was going to say that.
Because I need the h, don't I?
Yeah.
And isn't this already solved for h right here?
Yeah.
Yep. Okay, so h equals 1/4 times what? 6? Times 108 minus 6 squared is 36. Okay, so 6/4 would be what, 3/2?
Yep.
And 108 minus 36,
72.
72. That's what I got. And does 2 go into 72?
Yes.
Yep. 36. Is that right?
Yeah. Mm-hmm.
Okay. So is 108? That's not right. Cannot be 108.
It can't be?
Oh, can't be. No. No. What's the surface area?
108.
108. It cannot be 108. I mean, that's impossible to have it as 108. Okay, what did we do wrong? Where did I plug it in? I feel like something went wrong. What went wrong?
I just love math.
Squared. Well, I plugged it in here. That's where I plugged it in. Well, let's try there. If I plug it in here to this one right here, because it should work there too, shouldn't it?
Mm-hmm.
Okay. So if I plug it in there, I get 108 equals 4 times 6 is what?
24.
24 h plus 36, right?
Yep.
Well, then you subtract 36 and get 72 and divide by 24, which is 3.
So h.
H equals 3. But we should have gotten 3 before, shouldn't we have? So what did we do wrong? Oh, where is this x, guys, right here?
No, it's in the denominator.
It's in the denominator, not the numerator, is it? So let's go back here.
So it'd be h over.
So a 1 over 24, wouldn't it?
Yeah, 24 times 72.
So this would be 1 over 24, and h would is 72 over 24, which would be what? 3?
Yes.
Okay, so that makes a difference. If I would have made my division sign bigger, would I have noticed that? Probably. Okay, but the question are, what are the dimensions? Well, this isn't we have an h and we have an x, right? So x was 6.
Yep.
So our dimensions of this box are what? 6 by 6 by 3 what? Inches?
Yes.
And technically, I guess we should have inches on each one, shouldn't we? Okay. So how did we do this problem? What did we do first?
We found the two equations that we needed to do.
Correct. We found the two equations we needed to do. We identified which one we were going to ultimately be working with, didn't we?
Yes.
Okay. And then we solved the secondary equation. We call this primary and secondary. We found the secondary equation, solved for the variable, plugged it in, simplified, found the what?
The x.
Derivative.
And then
Okay.
we found the x.
Then we found the critical number because we know that tells us max or min, correct? And then once we found it, we plugged it in and found the other one.
H.
Okay, so if you want it in complete detail, this is in the book. It's on page 219 if you care. But is that what we did? Did we identify the given quantities? Yep. Did we get a primary equation?
Yes.
Yep. And then we did a secondary equation. We solved it, plugged it back in.
Yep.
We determined the domain that we could use.
Yep.
And then we plugged it back in to find the minimum or maximum value.
Yes.
That's what you're going to do.
That's a lot.
It's kind of. Hardest part's going to be identifying your two equations, I bet. Should you draw a picture?
Yeah.
Yep.
What's the primary equation again?
Primary is the one that you're going to be working with. Like the last problem said, what is the dimensions that will provide the maximum volume? Oops. Provide the maximum volume. So that's going to be my primary. Okay. So my primary is what I ultimately want to work with. Now, I've known people that don't pay any attention to that, and they work it out, and they're like, oh, I found this one. Now I got to plug it back in and find this. Well, why not just work with what you need to work with? You know?
Because why not make things harder?
I know. You guys do it so well anyway. Okay, so a rectangular page contains 24 square inches of print. The margins on the top and bottom of the page are 1 1/2 inches, and left and right is 1 inch. What should the dimensions of the page be so the least amount of paper is used?
I feel like I should write the problem.
Well, we're going to draw a picture. So, I mean, that's up to you. Okay, so first of all, let's draw a picture, right?
Yep.
Okay, so our page... Actually, I don't want to make my picture too big because I don't have a lot of room. And my page looks really square.
Isn't that how all pages are? No, the rectangle.
Yeah, rectangles.
But do you know a rectangle is square? Got you there.
No, a
Yes.
square is a rectangle.
Ugh.
Okay, so it says the top and bottom are 1 1/2 inches, right?
Yep.
Okay, so this is 1 1/2. And this is 1 1/2. Correct?
Yeah.
And in between it, we'll call it X. Does that work for everybody?
Yep.
1 1/2 on the top, 1 1/2 on the bottom, X in the middle.
Yeah.
Okay, then we got to get the sides. How much are on the sides?
1 inch.
1 inch. So there's a 1 and there's a 1.
Mm.
Well, in between those, we probably just better call it a Y.
Yep.
Yep. So there's our page. Well, I know that the rectangle page contains 24 square inch print. That's inside, right?
Yes.
And it says, what is the dimensions of the page? So the page is going to be your primary equation, isn't it? The area of the page. But the area of in here is going to be my secondary, isn't it? Okay. So that's going to be 24 equals what? What makes the 24?
The whole page.
Nope, not the whole page. Just the inside.
Just the inside.
What are the dimensions of the inside? x and what?
Why?
Y. Because the inside is without the margins, isn't it?
Yeah.
So it's 24xy. Wouldn't that be the area?
Apparently.
In that area? X times y?
Yeah.
Yeah?
I'm just really confused.
About what?
Like, because I thought X and Y is like the whole paper.
No, x and y is the area, like, x is from here to here.
Okay.
And y is from here to here. Because the margins are outside that.
Okay.
Okay? Because the 24 square inches is inside the margins.
Yes.
Okay, so that's that. So we're looking for the area of the whole page now. So area of the whole page, which is going to be my primary equation, is what? It's something times something, yes?
1/2 times 1.
1/2 times 1.
Because
Well, the area, the page is the whole page. So what is this whole side here, guys?
1 times Y.
Not times. I have 1, y, and 1. What's the length of that then?
2Y.
Not 2y. I have 1 and 1 are 2
Yeah.
plus y. Yes? Isn't that length 2 plus y? Yeah? I guess that's the width. What's the length of the paper? That's this.
Be 3.
It'd be 3 plus x. Okay, where did the 2 come from?
From the 2.
The 2 margins, right? The inch on each side?
Yes.
Okay, where'd the 3 come from?
From the other
The
2.
1.5 and 1.5, right?
Yes.
Okay, so we now have a secondary equation and a primary equation.
Yep.
So we would probably want to solve this in terms of x just because our brain likes to work with x better than y. Only reason. We could do y if we wanted to. So we need to solve the secondary for y and substitute it in. So how would I solve this for y? What? What does that say?
Divide by X.
Okay, divide by x. So y equals 24 over x. Correct?
Yes.
So now I plug that in for what?
What?
Plug it in for y. So I have 2 plus 24 over x times 3 plus x.
Now do distributive property.
We could distribute it if you want, or we could just do the product.
Okay. I'm not doing that.
You're not doing the product?
Like the product rule?
Yeah. I'm going to write this as 24x to the negative 1. Everyone okay with that?
To the...
How did it become 24x to the negative 1?
Because the X was on the bottom, so you have to bring it to the top and that brings it.
Right. Because then I can take the derivative easier, right? Okay, if I do not use the product property and I multiply this out, are things going to get a little hairy with that x in the denominator? Yes. So let's just use the product property. How about that?
Yeah.
Okay, so dA, dt, not dt, dx. I was doing my change about time. So you do it and I'll do it. Actually, it wasn't too bad, was it?
A what? I don't know.
So the derivative of this would be negative 24x to the negative second times the second, which is 3 plus x, plus the derivative of 3 plus x is 1, isn't it? Times 2 plus 24x to negative 1. And here is where you guys need to work a little bit more. Is what do I need to factor out of that? I have this term here and this term here.
Factor out 4x to the negative 3.
We can take 2, not 4. Because we have 2 and 24, which only have a 2 in common. Correct?
Yeah.
Wait, I'll show you. This would be 2, 1 plus 12x to the negative 1. Yep. Okay. So we can factor out a 2. And we have to factor out x to the negative 2. Why do we have to factor out x to the negative 2?
I don't know.
Because we can't have any negative exponents when we're done. Correct? So then I'm here. And we could take a negative if you want out, but it wasn't. Okay, so negative 24 divided by 2 is what?
Negative 12.
Negative 12. And x to the negative 2 divided by x to the negative 2 is 1. So we don't do anything with that, right? And you have 3 plus x. Now I factored out a 2, so that's gone.
So it'd be... What? Okay.
Wait a second. Wait a second.
Confused.
I think I screwed that up because that x is in there. I messed it up. And I'm glad I caught myself. I have to distribute this before I do anything. Why do I have to distribute that before I do anything? Because where is the negative exponent? It's stuck in here, isn't it? So since it's stuck in there, I've got to get everything out of there. So I got what? Negative
72 x to the negative squared.
and then minus 24x to negative 1.
Yeah.
And then plus 2 plus 4x to negative 1.
Yeah.
So I have these two zero out, don't they?
Yeah.
Oh, that's not much nicer. Okay, so now I have... We can do this. We don't even have to do it. So this would be negative 72 over x squared plus 2, wouldn't it?
Okay, why would you...
Okay, equals 0. So hopefully you would all subtract 2, yes?
Yes.
So negative 72 over x squared equals negative 2. And then we have to multiply by x squared and divide by negative 2. So negative 72 divided by negative 2 equals x squared. So 2 goes into 72 how many times? I forgot my squared.
36.
36. And the square root of 36 is?
6.
And?
Negative 6, 2.
Okay, so plus or minus 6. Now, can I have a minus 6 for my x right here? No. So x equals 6. So I can plug it right back in here and find y? Yes? So y would equal 24 over 6, which would be what?
4.
4. But that's only the dimensions of in here. I want the dimensions of what?
On the inside.
The entire surface
Of
area.
What should the dimensions of the page be so the least amount of paper is used? So now I need to plug these in to find here, right? So x plus 3. So x plus 3 is what?
Wait, are we using both?
Nine.
Negative 6?
No, because we have just x. You can't have a negative. By, and then 4 plus what? 2?
Yup.
And that's horrible. So 9 inches by what?
2.
No, plus 4 plus 2
6.
by 6 inches.
I'm not going to be able to do this.
Well, you sure, the great positive behavior. That's the way